find the resultant of these two vectors, we first need to redraw the vectors so that they are lined up. Sorry. We're going to line them up tail to tail. And this is going to give us a 90-degree angle because we know that one of the directions is due north and one is due east, and those two directions are 90 degrees from each other. And what we're going to do here is use the parallelogram law to find the resultant. The resultant is going to be something in between these two vectors. And the best way for us to solve for it is for us to draw the 51 kilometer an hour vector over here to make a right angle triangle between the 15 kilometer an hour vector and the 51 kilometer an hour vector. Our hypotenuse for a right angle triangle is the resultant, which I've labeled as vector r. So we can use Pythagorean theorem. That should have been an r squared. If we take the square root of that value, then we have the magnitude of resultant r, which is approximately 53.2. I've rounded off to 1 decimal place there. Now, in order for a resultant r to become a vector, we also need for it to have a direction. And so the direction is going to be angle theta between the east-facing vector and the resultant. And using our trigonometry, using SOHCAHTOA, we have the opposite and the adjacent side. And so if we were to use the tan ratio, we could easily find the value of the angle between them. So tan of theta is 51 over 15, which is 3.4. So using the inverse tan button on your calculator, you can calculate that angle theta is approximately 73.6 degrees. Now that's from the horizontal, or the east-facing vector. And when we talk about angles with vectors, we normally give those angles as either a bearing or a true bearing. In this case, let's give it as a bearing from starting at north, and we would then go 16.4 degrees east. So let's give that as our bearing, and so our resultant vector then is a magnitude of 53.2 kilometers per hour with a direction north 16.4 degrees east.